Section 2.3 is really heavy on definitions and a lot of problems that just ask you kind of to identify or classify, and not necessarily that heavy in the algebra. Usually I make sections P3, P4, and P5 not really a test, but I make a 50-point take-home assignment over these sections, which will probably be the case this semester. Anyways, the first term that we're getting is a monomial, and I wrote a definition. I'm not even that excited about it as I read it. A monomial is a variable, which is a letter with a whole number exponent. Whole numbers start at 1. They don't have decimals. They don't have fraction. So a number is a letter with a whole number exponent, like 1, 2, 3. You can't have fraction exponents. You can't have negative exponents. So a monomial is either a variable, a number, any old number. So this would be a monomial, like x to the 4th. That's a variable with a whole number exponent. This would be a monomial, y to the 17th power. It's a variable with a whole number exponent. So that's one thing that could classify as a monomial. X to the 4th is considered a monomial. Y to the 17th is a monomial. Or it could just be a generic real number. It could be like the number 7. This would be considered a monomial. The fraction 1/3 would be considered a monomial. So these are all examples. This is a single variable monomial, a single number monomial, or it could be a multiplication of one number and multiple variables, like something like this, like 7x squared. This is a multiplication of a real number times a letter or a variable with a whole number exponent. It's just a single term. This is considered a monomial. Could be something like this, 8/17 x y to the 4th. This would be considered a monomial. It's a multiplication of a number and two variables, and each of the variables has whole number exponents, like 1, 2, 3, 4, 5. So it's just a single term in some sense makes a monomial. A monomial can have a fraction, but it can't have a letter in the denominator of a fraction, nor can there be addition or subtraction signs between multiple terms. So a monomial is as simple as we can get: a single letter with an integer, positive integer exponent, whole number exponent, single number without a letter, a number multiplied by a letter with an integer exponent. They can have fractions monomials, but the letters or the variables can't be in the denominator. And these first 16 problems just want me to classify something as a monomial or not. Problem 2 is a monomial. It's a number times a letter with a exponent that's a whole number. So this is a monomial. I don't really know what to write for an answer. I'm supposed to say monomial or not monomial, so my answer should just say monomial. Problem 4 is not a monomial. It's a single term, but that -2 exponent makes it not a monomial because you can't have negative exponents. Problem 6, this is really -1 times z to the 8th power. It's a number times a letter with a whole number exponent. This is a monomial. I'm just going to write m for my answer, meaning it's monomial. Problem 8, doesn't matter if the number is positive, negative. It could be a fraction. It could be a horrible, disgusting number like the square root of 2. But this is a number, and then it has multiple letters multiplied, but neither the letters aren't in the denominator, which that would make it not a monomial, and the letters have nice exponents or nice counting numbers in some sense. So this is also a monomial. 10 has a fraction, which is fine. The number can be anything. If we have letters There can't be addition signs between the letters. I didn't mention that, but it wasn't kind of applicable to these problems. But the letters can't be in the denominator of fractions, which they aren't here. They're kind of written to the right. That's kind of implied in the numerator. They're definitely not in the denominator of the fraction. And none of them have exponents that would violate these being monomials, this being a monomial. In problem 12, the exponent of -5 makes this not a monomial. In problem 14, the letter x being in the denominator makes it not a monomial. And in problem 16, a letter being in the denominator and a letter having a negative exponent makes it not a monomial. So this is just simply just identifying what a monomial is. Simply, it could just be a plain letter with an integer exponent, could be a plain number, or a combination of a number times one or more letters with integer exponents, whole number exponents, positive numbers, bigger, 1, 2, 3, 4, 5, and on. Problems 17 through 28, each problem has a monomial, and in a monomial, we have to determine the degree of the monomial and the coefficient. So in problem 18, if there's just a single letter, the degree is just the exponent of that letter. So in problem 18, 9y to the fourth is a monomial. I would say it's a fourth degree monomial because the exponent of y is 4. And we learned coefficient back in section P1. The coefficient is just the number 9. In problem 20, there's an implied 1 written to the left of the y to the 7th. This is a single variable. It's a monomial. The degree is just the exponent of the y. It's a 7th degree monomial. And the coefficient, I'm just going to write c, is the implied 1. In problem 22, single variable, that y has an implied exponent of 1. We say this is a first degree monomial. The degree is 1. And the coefficient is the fraction in front, which is 4/5. When we have multivariables, more than one variable in a monomial, to get the degree, you add the exponents. So in problem 24, this is a monomial that's 2 variables as opposed to 1 variable. The degree of that monomial is 11. This is going to be important when we start adding and subtracting monomials. Usually we write the individual monomials highest degree to lowest degree. The coefficient in problem 24 is the 2. In 26, I really need to think of this as -1 times y to the first times z to the second. I'm going to add the exponent of the y and the z to get the degree. The degree is going to be 3. The coefficient's that -1 that was implied in front of the y. 28, I need to think of this as -1, a to the second, b to the first, c to the first. I'm going to add the 2 plus 1 plus 1, the exponents, and get a degree of 4. And the coefficient, that's implied -1. Still, another group of problems that are just definitions, so they go kind of fast. And the definition that we're going to deal with now is polynomial. And a polynomial is either just a monomial, a single monomial is considered a polynomial, or it's a combination of sums and differences of monomials. And then the individual pieces, the individual monomials that make up a polynomial is called a term. For example, if I wrote something like this, 6x squared plus 7x plus 5, there are 3 monomials. 6x squared is a second degree monomial. 7x is a first degree monomial. And if a monomial doesn't have a letter, it's considered a 0 degree monomial, because really 5 is the same as 5 times x to the 0, because x to the 0 is 1. So this is a monomial. This is a polynomial. A polynomial is either just one monomial or a sum or difference of monomials, meaning separating monomials with addition or subtraction signs. I could have changed a plus sign to a minus sign. It would still be a polynomial. This polynomial has three terms. The terms are 6x squared, 7x, and 5. And in polynomials, the terms are only separated by addition and or subtraction signs. You never have multiplication signs in a polynomial. The polynomial that I wrote here had three terms. This is first term, second term, third term, or highest degree term, second degree, middle degree term, first degree, lowest degree term, 0 degree. This is a polynomial with three terms. It's called a trinomial. A polynomial with two terms is a binomial, and a monomial is a polynomial with one term. So this would be like an example of a monomial that has more than one variable. Here would be an example of a binomial, two monomials, separated either by an addition or subtraction sign, and that's an example of a trinomial. And when I write binomials and trinomials, it's proper to write the highest degree term first and the lowest degree term last. In this particular problem, that was a second degree term, because the exponent of the x, and only had one letter, was 2. That's a first degree term. And I should have probably thrown this in the other section, but constants we call 0 degree terms, because any constant can be changed into something that has a variable by tacking on a variable with a 0 exponent. So in the problems 29 through 44, which are about to come up, we're supposed to determine whether what's listed as a polynomial or not, and if it's a polynomial, classify it as a monomial, binomial, a trinomial, or if it has more than three terms, we'll just call it other. A polynomial with more than three terms, we just call it, doesn't have a special name, it's just an other polynomial. So in problem 230, should I say, I want to determine if this is a polynomial. To be a polynomial, you need to have monomials that are added or subtracted together. That's a monomial because the exponent's a positive 1. That's a monomial because it's a constant, and plain numbers are monomials. So this is a polynomial. So I'm going to say this is a polynomial. So is a polynomial. And because it has two terms, it's a binomial. So it's a special kind of polynomial. It's a binomial because it's a polynomial with two terms. I guess if I was answering this, I'd say P for polynomial, B for binomial, and just call it at that. For problem 32, it could be a polynomial because each of the terms is separated by either a plus or a minus sign. It can only be a polynomial if each of these is a monomial. To be a monomial, a single number, single letter, or a number multiplied a letter by an exponent of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a monomial, that's a monomial, that's a single number, that's a monomial. So this is a polynomial because the signs between the terms are addition or subtraction. That's the only signs that are allowed between my terms. And each term is a monomial because each term is either a single number, a single letter, or a number times a letter, or letters with integer whole number exponents. And this is a trinomial. I'm just going to put T for my answer. So it's a polynomial because it satisfies, it's a sum or addition of monomials. And it's a trinomial because there's three terms. But P and T would probably be fine. Problem 34 is not a polynomial because of this exponent of -2 makes that term not a monomial. To be a monomial, you need to only have exponents like 1, 2, 3, 4, 5, 6, 7, whole numbers. Because it's not a polynomial, probably I'm not going to call it a monomial. Quite honestly, at some point during the semester, I might refer to this as a monomial incorrectly, just meaning the mon meaning it just has one term. But I don't need to classify it because I only classify it if it says if it's a polynomial, classify it. If it's not a polynomial, I'm not going to classify it. And for an answer here, maybe I would just write NP and stop. Similarly, 36 isn't a polynomial because this term right here isn't a monomial. Monomials can't have letters and denominators. So for my answer, I might just say not a polynomial. Because it's not a polynomial, I can't really call it a binomial. 38 has a letter in the denominator and it has division. You can't have division in a problem that is a polynomial. You can't have letters in a denominator, so that's not a polynomial. 40, 8x is a monomial. It's a number times a letter with an exponent of 1, which is an acceptable exponent. 2y is a monomial. It's a number times a letter with an exponent of 1. 3z is a monomial, and a single number 1 is a monomial. So all four of those are monomials. There's only addition and subtraction between them. So this is a polynomial, but it's not a specially named polynomial because there's 4 terms. And so polynomial with 1 term is a monomial, 2 terms a binomial, 3 terms is a trinomial, and I didn't mention it, but if it doesn't have 1, 2, or 3 terms, we'll call it an other. It's not a mon, bi, or trinomial. So for an answer, maybe P and other. So you could see that. Yeah, I guess you could. A few more classifyings here that just spilled over to a second page. In 42, this term is a monomial. It's a number and multiplied by a string of letters. All the letters have exponents of 1s, which are acceptable exponents, and the letters aren't in denominator. That's a monomial. And a single number is considered a monomial. Subtraction sign between good. So that's a polynomial. And because it has 2 terms, it's a binomial. In 44, the fraction and the x in the denominator make it not a polynomial. The next few problems talk about the degree of the term, the degree of a polynomial, and the degree of a term. So in the world of a polynomial, each term has a degree. It's either the exponent if it just has 1 letter, or the sum of the exponents if it has multi-letters. And so let me try to break this down. I make these like things to help me up here. What I'm supposed to do for each of the problems in 45 through 56 is do 3 things. First, I'm going to state the degree. Oh, no, I'm not. I'm going to look at each term and find each term's degree first. That's going to help me answer the questions. There's 3 questions that I need to answer, and let me just try to illustrate what I need to do and what's written up here by looking at this problem 46. In problem 46, this is a polynomial. The first term is a 3rd degree term because it's 1 letter and its exponent is 2. The second term, it's a monomial, and that's a 2nd degree term. In a binomial, each of the monomials is called a term. So the binomial in problem 46 has 2 terms. In the world of polynomials, the term with the highest exponent is called the leading term. So in this particular problem, it has 2 terms. It doesn't matter which one is written first. In a polynomial, the leading term is the term that has the highest degree. And in this case, it's x cubed. So in the world of this definition right here, the leading term of the polynomial is the term in the polynomial with the highest degree. And the first thing I was asked to do is to identify the leading term of the polynomial in problem 46. So I looked at the two terms, found the degree of each. It doesn't matter which term is written first, which term is written second, or which term is written third or fourth. The leading term is the term with the highest exponent. Now in the world of what comes up next, then it says state the degree of the polynomial. This polynomial has a degree equal to the term, the degree of the highest, of the leading term, should I say. So the degree of this polynomial, we call this a third degree polynomial because the leading term has a degree of 3. So the degree of a polynomial is simply it's the degree of the leading term. So the leading term is the term that has the highest degree. The degree of the polynomial is the degree of the leading term. And lastly, the leading coefficient for a polynomial is the coefficient of the leading term. So the leading term, or the term that has the highest degree, it gives you the degree of the polynomial and the leading coefficient of the polynomial. So for this polynomial, it's a third degree polynomial. The leading term is x cubed and the leading coefficient is 1. When I look at problem 48, it's a binomial. The first monomial, or the first term, is a first degree, or it has a degree of 1 because the exponent on the z is 1. The second term has a degree of 3 because I just add the exponents of the x and the y and get a 3. So in the world of problem 48, the leading term, even though it's written second, is the 5x squared y. When I talk about the degree of the polynomial, it's just the degree of the leading term. So the degree of the polynomial, 9z plus 5x squared y, is 3 because that's the degree of the leading term. And the lead coefficient is the coefficient of the leading term, which is 5. If I wanted to do the same for problem 50, it's a trinomial. It has 3 terms. The first term has a third degree. The second term is degree 4. The third term is degree 1. So it's 3, 4, and 1. So in problem 50, this is the leading term because it's the term that has the highest degree. So in problem 50, the leading term is, I need the negative sign. It's negative y to the 4th. I could say it's negative 1y to the 4th, but it's important, if there's a negative sign, it's part of the term. That negative sign needs to be, part of my answer. So the leading term is the highest degree term, which is that 4th degree term. And the degree of the polynomial, I'll just write d for degree. This is a 4th degree polynomial because the degree of that term is 4. And the leading coefficient is the coefficient of the leading term, and that's an implied negative 1. Last problem on this page, but these problems spill over. If I look at problem 52, I have a 4th degree term, a 5th degree term, a 1st degree term, and constants have a degree of 0. Numbers without letters have a degree of 0. So the leading term in problem 52, the leading term with the sign is the negative 2y to the 5th. If that was a plus sign, I wouldn't include the sign. The degree of this polynomial is the degree of that term, which is 5. And the leading coefficient is the coefficient of that term, which is negative 2. Two more of these problems, which are tricky because they're constants, but the same questions for 45 through 56. So since there's only one term, it's a monomial, this has to be the leading term. The leading term is 1. And I hate this part, but I have to live with it. The coefficient is the hard part, or the leading coefficient. I really have to think of this 9 as 9 times x to the 0 if I want the x to be the variable, because this is really x to the 0 is 1. This is 9 times 1. If there isn't a letter, that number is considered the coefficient. And for the degree of a number without a letter is 0. So my answers, if there's just a single term and it's a number without a letter or a constant, it is the leading term. And the leading term should just be, I should say the leading term is 9. I don't know why I wrote 1 there. Sorry, I make mistakes. But the leading term is the whole monomial. It's the only term. But a number without a letter is its own coefficient, and numbers without letters have degree 0. Similarly, in problem 56, the leading term is the negative 4/5. Its leading coefficient is still the negative 4/5, and constants have degree 0. This is probably a nice place to stop this video. There's not much left, but it's different enough, and I'm going to take some time with it. So let's make this into a part 2.